PEAT is also developed to run Monte Carlo risk simulation at very high speeds. So assuming again that we're in the discounted cash flow module where we have multiple projects that's set up. Now what we've done is we've spent some time on applied analytics with static tornado analysis and scenario analysis. Now it's time to go to risk simulation. So if you go to risk simulation, now we're looking at dynamic and stochastic analytics or doing Monte Carlo risk simulations. So under risk simulation, you see 5 different subtabs of level 2. So let's go through each one of them. The first is to set input assumptions. So step 1 says choose an option to set input assumptions on. And if you recall, we have multiple projects, project 1 all the way to project 10. So let's just choose the project that we want to. And by the way, depending on the name of the project on the tab, this is what will show up. So if you named it something else, let's say, cash flow analysis for implementing a joint venture, this is what you would see on the name here. But for simplicity, I use project 1 all the way to project 10. So let's just choose the relative project that we are interested in. And I have this selected, step 1. Step 2 says click on the distributional icon, which are these icons right here, to set your input simulation assumptions. Now we can turn things on or off as we wish. So if I click on this checkbox, this is a set input assumption property dialog box will pop up. Or I can click on this as well, changing the settings. So there are different probability distributions, about 45 of these, and we keep adding additional distributions as well. Choose the distribution that you want to use. Notice that triangular, uniform, and normal are the 3 most commonly used distributions, and therefore they're listed up first. Everything else are listed alphabetically, like arcsine, Bernoulli, beta, all the way down to Weibull distribution. If you're interested in understanding what some of these distributions do, there's a short little description here, and you see the input requirements, the parameters that you need to put in. So it tells you that minimum has to be less than or equal to most likely, and so forth and so on. So let's just choose a triangular distribution if you want to, and we are doing a discount rate. The single point estimate, the user input, what you typed in originally, it was 10%. It gives you a frame of a point of view, a frame of reference. So in this case, it was 10%. So we can change the minimum, in this case 0.05 for 5%. Most likely we'll change it to 10%. Again, it's percent, so we just use decimal points. 0.15 in this case. Now we click OK. And we see that we've set up a triangular distribution, minimum, most likely maximum values. And you can see what those values are on here. And you can turn it on or off clearly. So just because an assumption is set up, you may or may not want to use it. You may want to use it in the future. You can turn it on or off in this case as well. So now, if you're happy with setting up all the assumptions that you want to, and by the way, you can set as many assumptions as you want. Let's say you're done with it, you can go and skip step 3 temporarily, go to step 4 and give it a name. So we'll call it this my model, for instance, and typically name it something that make a little bit more sense, hopefully. You can decide how many simulation trials you want to run. By default is 1,000. Typically, we recommend anything between 1,000 and 10,000. You can apply the seed value. A seed value simply means if you were to rerun the same model, assuming the same inputs and the same assumptions, same everything, you would get exactly the same results. All right? If you don't care, you can always turn it off by default. And we can do a save as, and you see your model is right there. You can delete it, you can edit it as required. Now, I have 2 additional models I have saved here, all simulation models. Let me edit this real quickly. So we'll pull it up again. And notice that it says all simulation models. What happens here is I've chosen project 1, and you see I've got some assumptions in here. I've got one assumption up here and probably another assumption somewhere down here, capital investment. And project 2, same thing. I have another assumption. Project 3, I have another assumption. Project 4. So what that means is I can create simulation assumptions only on an individual project per se. So I might just want to simulate this project by itself, or I may want to simulate all projects simultaneously. I can do that as well. So all you need to do is decide, do I want to simulate all options at once, which means all projects simultaneously, all 10 projects, or do I just want to simulate the selected option, the selected project in this case? All right. Typically, if you're looking at a portfolio analysis, I would want to simulate all projects, all options, if you will, simultaneously. So that's what I have here set up. And if you're ready, you're happy, you can simulate as many trials as you want, apply seed value and so forth. And click on that model I want and edit it. So when I click edit, it just pulls up the model and I can click on run simulation. Or I can just double click on the model and the simulation will run in this case. So notice that it runs simulation on all 10 projects and it ran relatively quickly. And when you're done, the software will take you automatically to the simulation results. So again, very easy for user. All you need to do is click on that assumption and put in your parameters, typically triangular, normal, or uniform, and enter in your parameters. That's all you need to do, as many as you wish. Then run it. You might consider saving those models for later retrieval. Again, you can save as many models as you want to on here. And when you do a file save, what happens is all the models that you've set up, all the assumptions and settings and so forth will be saved in a single file, your ROV project econ file. So here's the simulation results. And notice that we've got all 10 projects here, project 1 all the way to project 10, because I asked it to run all projects simultaneously. So choose the KPI, the key performance indicator that you care about, that you want to look at. Okay, so let's just say we choose MPV for simplicity for project 1, and this is your chart. Again, you can do a lot of things with the chart. You can copy the chart, you can go to Excel, PowerPoint, you can go anywhere, and you can paste it in on Microsoft Word, and you write your report as required. So here's your chart. Here are your results, your percentiles. 0% pertain to your minimum, of course. So this is your minimum value right here. 100% is, of course, your maximum value, which is your value here. So the delta, the difference between min and max, is your range. So the best, absolute worst case scenario and best case scenarios, okay, for your net present value. That's your min and your max. Trials, number of trials that you've run. In this short video, I run 100 trials. In real life, you do 1,000, you do 10,000 clearly. And here is your average, your mean. Okay, so on average, out of running 100 or 1,000 trials, here's your average NPV, expected value. Here's your median. If your median and your mean are fairly close to each other, it implies it's relatively symmetrical. Upside and downside are equally, probable in this case. Otherwise, we would see a high skew. So in this case, there's a small little skew because they're relatively close to each other. So a negative skew, a small little negative skew, which means the tail points a little bit more towards the left, is pulled to the left itself, which is a good thing because you want to have a high probability on the right side, in this case, of NPV. CV is a coefficient of variability, or coefficient of variation, and that's nothing but standard deviation divided by the mean. So the spread divided by the average, and because it's dollar divided by dollar, in this case NPV, you get a percentage. And typically we use CV as a proxy for volatility, for uncertainties. So now you can compare project 1's CV, compare the project 2's CV, project 3 and so forth, and identify which one has a higher level of variability or volatility, which one has higher uncertainties, if you will. It may or may not imply risk because you may have a skewed distribution and you may still have a high CV, which is a good thing if you have a negative skew. So it implies that you have uncertainty, but the uncertainty falls all the way to the right side. So you have a high upside uncertainty, but it's upside, so that's a good thing. And here are your percentiles. Now we can also do a lot of things with the chart. Of course, you can change colors as you wish, zoom in, zoom out, all these things that you've seen before. On the bottom right, I can type in percentile, let's say 5%, and type in something like, say, 95%. So 5 and 95. So this is my 5th percentile line. This is my 95th percentile line. So in the body, it's 90%. So this is my 90% confidence interval. So 5% to the left, 5% to the right, symmetrically. So it tells you that the 5% tail right here, fairly difficult to read from the chart, so it returns the value for you, is 359,000. And the 95th percentile line is $696,000 in this case. That's my 90% confidence interval. You can also change the value itself and say 400,000. Okay. And by the way, when you're typing, the cursor is still in the box. So the software doesn't know if you're done or not. So make sure you get out of the box, click somewhere, okay, or hit tab on your keyboard, and it will tell you, it will calculate that this is the 10.67 percentile. Okay, for $400,000. That's for 2 tails. You can also do just a left tail. And let's just see what's my worst case scenario, 1% of the time, which means 99% value at risk. So 99% of the time, you will still make $312,000 on this project and it's positive NPV. That's a pretty good project then, it's positive in value. Or you can actually type in something like $450,000 and see what's the probability it will be less than 450K. In this case, it's 20.44%, which means on the right-hand side, just take 1 minus that, which is close to about 79.5%, 56%, okay, rounded. So you can calculate your probabilities in this case, or you can type in certainty values. Let's say the value 500,000 has some level of significance for you. So we'll put in 500,000 in this case, and we'll click update. Okay, for whatever reason you want to just show that line, and this is your line. You can add up to 4 lines in this case, certainty values based on the dollar amount or based on the percentiles. I can also do a 90%. Click update, and this is your 90% line. So you can add up to literally 8 lines, if you will. You can show grid lines if that's helpful for you to identify and read the chart. Click again to get more granular grid lines. Click one more time to take it off. Again, at this point, you can copy the chart and paste it into Excel, PowerPoint, or Word. You can change the different types of charts on here: S-curve, area curve, PDF, CDF, whatever you need in this case. So whatever you want that's appropriate. So let's just keep it at this point, and we'll click update, and it will show those 2 lines for me. Now, what I can do is add a couple of data labels, change the bar colors. I can even do a save, and I can save this file itself so that in the future I can open up this file so I don't have to rerun the model. So this is a fairly functional tool, if you will, if you just want to save a lot of different charts for archiving purposes and so forth. Or if you want, you can make data labels, okay, turn it on or off, look at the percentiles, or customize text. So if I click on custom text properties, notice that I have 2 lines in this case, 2 red lines which I entered at the bottom. So now I've got 2 vertical lines. I can choose the vertical line that I want, change the header in this case. So this is my chart. If I wanted to put a title in there if I need to. I can also add and change different text. So for example, I can change the text properties, and we'll call it, my important line, for whatever reason. And you can change the text properties, and the text properties could be different font sizes. I can change this from size 12 to size whatever I want, 14. Change the color of this, different font, change the color of the font, color of the line, the size, the location, line type in this case. Okay, make it a little bit wider, make it less white, and so forth. You get the idea. And when I'm done, this is what will happen. And I can move my text up, down, left, right, and so forth. All right. And because there are 2 lines, I can choose the line I want to make modifications on. So now that you're happy with this, again, you can click save to save the file, specifically this chart right here, to your own file, and you can resurrect that file later on, this chart later on if you want to. So that's your simulation results. Many things, a lot of functionalities that you can play with. You can also click on overlay results. Overlay results just overlay multiple charts. Remember, this one here is just a single chart. This is just NPV for project 1. But what if you want to compare NPV for project 1 and NPV for project 2, and maybe even NPV for project 3, and so forth and so on? You get the idea. So now, we only ran 100 trials, so your charts will be a little bit, jagged and so forth, not as smooth. If you ran, 1,000, 10,000 trials, your charts will be a lot smoother. But just even using a very simple, calculation with 100 trials, you can see that project 1 up here in blue, NPV, is towards the left-hand side. So what that means is, and on the x-axis we have NPV because we're looking at net present value, of course, at this point. So clearly you want something that's to the right because it's higher net present value. So project 1 has a lower NPV, expected value, than project 2. And project 2 has a wider dispersion, a wider coefficient of variability, a wider level of uncertainty. But notice that the level of uncertainty is mostly on the upside of project 1. So by just looking at a chart like this, I would say, I would go with project 2 probably, because it has a lot of higher potential for uncertainty on the upside, and the expected value, the mean, the average is probably the expected value is on the right hand side. So it's higher upside potential and higher expected value of net present value. Again, you can do a lot of chart manipulations, data labels, copy the grid lines, copy the charts and so forth. You can also go to analysis of alternatives, or AOA, and here you have multiple options as listed, and choose the economic results that we care about. Is it NPV, IRR, those key performance indicators. So let's just choose NPV, and we'll say CV, coefficient of variability. So we can very quickly compare all 10 options, all 10 projects. Again, you can change a different type of charts, in this case a bar chart, and we can see that option 4, project 4, has the highest volatility, has the highest level of uncertainty in this case. We can look at mean or expected value and say, clearly don't do project 8. Projects 9 and 10 are really, subpar. Projects 7, 1, and 2 are relatively decent in this case. We should, at least consider these. And you can see the numbers right here as well. 8 and 9 are negative, clearly. So try not to implement those, right? You can also do a value at risk. So value at risk of 5th percentile, which means, worst case scenario, 5% of the time, which means 95% of the time, project 1 will still get you $359,000 positive. Okay, there's a 5% chance that project 4 in this case will return an NPV that's negative $13,000 in this case. So we can use this as a good indicator, as a comparison across all projects simultaneously. And this is analysis of alternatives, which means AOA. There's no base case. We're looking at all of them, per se, by themselves, independent, or you can look at incremental analysis. So if you choose incremental analysis, you have to choose a base case. So we'll choose project 1 as a base case, for instance. So anything that's non-project 1 will be the delta, the difference, if you will. So you can actually look at the differences. So project 3 compared to project 1, project 3 is a negative of $525,000. So what that means is you can look at project 1, project 3. The delta in this case is indeed, a big difference, a negative $500 over $1,000. Comparing project 1 and 2, project 2 is better, but at upside of more than $500,000, approximately $500,000. So I can do a $600,000 in this case. The math is done for you. So this is incremental analysis. Just to look at a base case and anything, the delta, anything above and beyond that, right? It could be positive or negative. Decimal settings, chart settings and so forth. Dynamic sensitivity, I just ran a very simple calculations with 2 input assumptions. Now, if you have more than 2, clearly you would see a lot more bars in this case, and you can choose whatever variable that you want to look at. So in this case, project 1's NPV. Again, I only had 2 assumptions, but if you have multiple assumptions, you can see the rank correlation, which is nonlinear. Okay, so discounted cash flow has the highest impact. Okay, and on contribution to variance, we can actually see by looking at discount rate by itself, it accounts for 86.31% of the variation of my net present value. So clearly, having 2 assumptions is not as fun, but if you have multiple assumptions, you can run this and you can see the top 3 or the top 5 or the top 10 simulation assumptions, the settings, account for 80% or 90% of the contribution to variance, contribution to the uncertainty, to the impact of your net present value. So this is dynamic or stochastic analysis under risk simulation. But before you can do all this risk simulations, you still need to have your data populated. You need to have your KPIs, your economic results, key performance indicators computed. We would recommend going through from left to right, making sure that you've looked at your static, your scenarios, and identify which are your critical success factors before you set in the assumptions, because otherwise you won't know which assumptions to set. So clearly do not set assumptions on something that has extremely low impact on your NPV, on the key performance indicator that we're looking at. So whatever has high impact and yet at the same time has a lot of high variability and uncertainty. So even if you have some variable that has high impact but is a known variable, like investment cost, for example, that is contractually obligated, then clearly that's something that you do not want to set an input assumption on. So it has to be high impact, and at the same time it is relatively uncertain. That's what you would do, and you would come into risk simulation, set input assumptions, select the option that you want, and set the distribution and then run the simulation. And don't forget to save the models. All right. So this is dynamic or stochastic simulations in this case.